Okay, welcome to the video for writing the chemical formulas of ionic compounds when you're given the name. So for example, if you're starting off with sodium sulfate, could you write the chemical formula? And by the way, I'm going to make a correction here. This is the correct chemical formula for sodium sulfate. Okay, so what do we need to do for that? When you're given the name tells you the cation, which is written first, and then there's a space, and then there will be the anion. So you know the names of the cation and anion. What you need to do is to identify, well, what does the chemical formula of the cation and anion look like? What do the element symbols or polyatomic formulas look like? And then also, how many are you going to have? And that last part is sort of the trickier part. Determine how many of each you have will depend on the charges for the cation and anion. So what I'm going to do is I'm going to do some work here, and then at the end I'm going to clean it up. That's sort of how you have to do this. So it's sort of a little bit of a multi-step process. Okay, so my first one here I have aluminum sulfide. All right, so remember this is my cation part that I'm starting off with. So there are two places I'm going to look for what aluminum is, what its element symbol. If it's a cation, it's most likely going to be on the metal side of the periodic table. So I'm looking for aluminum, okay? And boom, here it is. Now the only exception when I wouldn't use the periodic table for my cation is for ammonium, NH4 plus ammonium. So this I would have to use the polyatomic ions, okay? But let's start off with, in this case where we have aluminum and the chemical symbol is Al, okay? All right. Now the other thing that I'm going to need to know for this aluminum, I'm just going to write it above it and do my work, clean up my work at the end. The other thing I need to know for aluminum is what's its common charge. So remember, if you are in groups 1, 2, and 13 all the way to technically 18, although for the noble gases we don't worry about them for naming, but for 18 to 17, let's say, they all have common charges. And you can see that on page 1 of your packet. So here are the common charges. All right, so let's figure out what group aluminum is in. Aluminum is in group 13, and these have a +3 common charge. And one thing you should notice, the pattern goes +1, +2, +3. This is really +4, in some cases minus, but usually just +4. And then it starts going to the negative side, -3, -2, -1, 0. Okay, so here it is. Aluminum is in group 3, so it has a +3 charge. So I'm going to write that above it as well. So I identified it in the periodic table, get the symbol, and then I use my common charges to figure out the charge. The next one I have is sulfide. Now this is the important part. Notice the suffix is IDE. That's going to give me a clue of where I'm going to look, because for anions there are two places you definitely can look. Periodic table, or again this chart. Now if the suffix is IDE, you're going to look in the periodic table. Because remember, when you have that IDE suffix, it has to come from the periodic table. So that IDE ending tells me I'm looking here. So I need to look for something with a sulf as in the beginning of its name and then something else. And that sounds like sulfur to me. So I'm going to look for sulfur, and here it is. Okay. So the symbol here is S. All right. Now I need to figure out its common charge. So once again, I use my common ionic charges chart. Sulfur is in group 16, which means it has a -2 charge. Now, if you're not sure, if you're like, oh, I have to keep flipping back and forth, you want to start looking for a pattern here. Because I actually knew it was -2. I didn't need to look. Because I recognize the pattern. It goes +1, +2, +3, +4. And then here, it starts to go down to the negative side, -3, -2, -1, 0. So if you know that the last group is, the noble gases have a 0 charge, and then this group here has a +1 charge, that sort of can help ground you into where you need to go, okay? But anyway, sulfur has a -2 charge, okay? Now, how are we going to use that information? The next step is to figure out, now that we know our symbols, how many of each that we need to have. Now, in the case of aluminum sulfide, we want the overall charge to be 0. But if you add up +3 and -2, that's not going to give you an overall charge of 0. All right, so in this case, we need to have more than one of each. We need to have more than one of each, all right? So how can we figure that out? what you're looking for is a common factor that can be used to give you an overall charge of 0. When I see +3 and -2, I'm thinking about +6 and -6 adding together. And to get this to be +6, I would need 2 aluminums. And to get this to be -3, I would need 3 sulfurs. Okay? So that gives me, so what that tells me is I'm going to have a chemical formula where I have 2 aluminums. So instead of writing the 2 in the front, I'm going to write it as a subscript next to on the lower right side, and 3 sulfurs. So I'll take that 3 and I put it here. And that's the chemical formula. Now, there is a trick for this. You can use what's called the crisscross method when you're dealing with these sort of numbers, where whatever the charge is for the anion, that tells you the number of cations that you would use, and whatever the charge is for the cation tells you the number of anions. So you can use that trick sometimes, but you always want to check your formula and make sure it makes sense. And what I mean by that is these numbers need to be in the lowest number ratios. Like if I had a 4 and a 6 here, I could simplify those to 2 and 3, so that wouldn't be correct. But this is the correct formula. Okay, let's go on to the next one. Same process. So first, I'm given the cation, and for the cation, I'm going to start looking in my periodic table because that's where most of my cations are. So this one's magnesium, beginning with an M. And here it is in group 2. So since it's in group 2, I know it has a +2 charge. So above this, I'm going to write Mg2+. And the next part I have is selenide, IDE. So am I looking on the periodic table, or am I looking on my polyatomic ion chart? Well, if it has an IDE ending, I'm going to look on the periodic table. Okay, so selen, I'm looking for something that sort of starts that way. And the cool thing about the anions is that there are very few of them, and here I have selenium, so it's got to be that one. So I'm going to go ahead and select that. Okay, and that's Se. Now for the charge on selenium, for the charge on selenium, I need to go and figure out what group it's in. It's in group 16. This group has a -2 charge. So I'm going to have a -2 charge here. And notice that I've been writing it 2 ways, either 2+ or +2. This is the convention, is to put the number first and then the charge, but it doesn't really matter. Okay, so now that we have this, now I need to figure out, well, how many of each of these do I need to have an overall charge of 0? Well, let's look at the charges. If I add them up right now, +2 and -2, that will give me 0. That means I need just one of each. So this is going to be Mg Se. That's a pretty easy formula to draw. All right, last one. Silver phosphate. So again, I'm starting with silver, which is my cation. Most likely I'm going to find that in the periodic table, unless it's ammonium. And it's going to be a metal. So I'm looking in my periodic table. I'm looking around, looking for silver. Silver's a transition metal. Here it is. It's weird, it has the symbol Ag. So that's the symbol I'm going to use. Oops, let me do it over here first. Now, silver is a transition metal, and most transition metals, which you'll see in a moment, their charges vary. The only exception, zinc and silver, they do have common charges. So zinc has, its common charge is +2, and silver is +1. So that means, in this case, I know the charge is +1, all right? For most transition metals, you can't tell by just looking at where it is in the periodic table, but these two you can. So silver is +1. All right, so now I'm gonna go look for my anion, which is phosphate. Phosphate, oh, this ends in an 8. So do I look on the periodic table or the polyatomic ions? That's right, the polyatomic ions. The only time you look on the periodic table is if it ends in IDE, I-D-E, not I-T-E, but I-D-E. All right, so I'm looking for phosphate. And here it is, begins with a P, so it's easy to find. Here we go, phosphate, PO43-. I go ahead and write that down. Okay, and now what I'm going to do is I'm going to figure out how much of each of these do I need to get an overall charge of 0. If I add +1 and -3, that doesn't work. That won't give me 0. So that means I'm going to need more of at least one of them. And in this case, in order for it to balance, since I have a -3 charge here and only have a +1 charge here, I'm going to need a total of 3 of these, okay? So 2 more, which will give me a total of 3. So my formula is going to be Ag3PO4, okay? Notice that in all of these I don't put the charges in, I just use the charges to figure out how much I need. But when I write the chemical formula, I don't write it with the charges. Okay. So once again, in this example, you could use the crisscross method, which I showed you previously, where you take the charge of the anion, and that tells you the number. So the anion has a 3 minus charge. That means you're going to need 3 of your cations. And then the cation has a +1 charge. That means you need 1 of your anion. Now, one thing I want to point out here is if you were to use the crisscross method for example number 2, then it would look like your chemical formula should be, and I'll just write it on the side, Mg2, using that 2 there, Se2. Now, Mg2Se2. The reason why this is incorrect is because, once again, you want the subscripts to be the smallest number ratio. 2 and 2 is not the smallest number. You can simplify these by dividing both of them by the least common factor of 2. So that's why this would not work. So if you're using the crisscross method, you always have to double check to make sure that your formula is correct and is simplified. All right, last little note here, because it wasn't shown in this example, but in some cases, you're going to need more than one of the polyatomic ion. And I'll give you a quick example. Let's say you have aluminum nitrate. Okay, so aluminum has a +3 charge. We found that on the periodic table before. And nitrate is a polyatomic ion with an NO3 minus charge. All right, in order for this to balance out, you're going to need 3 nitrates. You're going to need 3 of them and only 1 aluminum. So the formula would look something like this: aluminum, NO3. Now, how do you show that you have 3 of them? For the polyatomic, since they stay together as a group, you're going to group them in parentheses, and then you're going to put a 3 outside of the parentheses, which tells you how many of them you need, okay? So if you have more than one polyatomic, make sure you put the polyatomic in the parentheses, and then the subscript outside will tell you how many of them you have. All right, that is it for this video. You've got some practice problems to try. I hope you found that helpful. Have a quality day.